Hi, everyone. It's Lev here with Trotec Laser Canada. Welcome to this large format webinar. I have Renee Garcia here out of Calgary, Alberta, and Josephine Liu at our showroom in Mississauga. Awesome. Hi, everyone. So what we're going to do first is kind of different than the RayJet webinar where we kind of do the demo first. First, we're going to compare the main differences between a laser, more about like the large format laser like the SP2000, SP3000 versus CNC routers. Now, we're not going to, this isn't about who's better. Both technologies actually work hand in hand. One technology is good for one things, and the other technology is good for other things. So they're actually a complementary systems. So we would always recommend, if you're doing any type of acrylics or wood or foam, it's always good to have even both, depending on what application you're kind of wanting to go for. So without further ado, Renee actually has a very extensive experience with CNC cutters. Renee, if you want to kind of introduce yourself and tell everyone what your experience is with CNC machines.
Hello everybody. Thank you. I would like to tell a little bit about my experience. I've been around CNC machines for all of my life. So I used to work with milling machines and lathes and everything in CNC, and had the opportunity even to work with a CNC manufacturer locally in Canada. And in my experience with the CNC routers, I had the opportunity to teach the people how to program the machines, how to use the CAD/CAM software, and also how to even operate the machines. And I know all the capabilities of the CNC machines. I know what you can do. They're widely used in the science industry. There's a lot of applications you can do with the CNC. But also, now that we're talking about lasers, we can see the difference between one and the other, how they complement each other. I certainly know in which areas the CNC routers are stronger and which ones are the lasers stronger. So that's what I want to highlight, especially the benefits you can get with a big format laser machine that you can use. And in my experience, I've been looking into about doing channel letters and doing signage for indoor. And one of the things that I always was like wishing to have a laser was, especially when we needed to have a polished edge finishing, or when we needed to do some tight corners and things. So I'm going to be explaining step by step some points that I highlighted, which will be beneficial for having a laser that can complement what you cannot do with a CNC router.
Perfect. Thank you for that. So I'm going to add sort of the chart that we've had, and we can just kind of go down the list, the differences between a laser machine and CNC routers. I mean, a lot of this is for acrylics, but not only. So, Renee, I guess the first main kind of point that we would go through is the parameters. So, what do you mean when a laser machine has 3 parameters versus a CNC machine that has many parameters?
Exactly. So when you use a laser machine, especially with job control, we have a form. It's a page where you can set up all the settings you need for a machine, and you mainly need to work with the power, with the feed rate of the speed, and also probably the frequency, which is something that also is not very, very variable. So basically, you play with these 3 variables, and that makes it very easy to set up when you do a job. So especially when you choose one of our materials, you just click on the material. It comes with all those parameters preset. So by contrast, when you work with a milling machine, the people have experience, they know they have to set up many other things, like the tool radius of the tool radius, which is important, or the diameter of the tool. You have to set up the height or the length of the tool. You have to set up feed rate. You have to set up the spindle speed. And you have to set up, probably some other parameters that are really, really related to the tool you're using. And even though you set up previously, each time you change tool, these things can change. So it means the laser is very user-friendly in terms of the amount of settings you need. So that could cut a lot of time in programming, right?
So what would be like, when you used to work with the CNC machines, what would be an average setup time? Versus, I mean, we can ask Josephine. She's been working with the lasers quite a bit. I mean, what would be an average setup time for a CNC router system?
If you're starting for the first time, of course, you will spend probably at least between 15 to 30 minutes just setting up the tools, compensating the tools, loading them. If you have to put the tools in the machine, in the magazine, you have to use the clamps, you have to use everything. At the very beginning, you have to set up all the tools. It could be even more depending on the number of tools. But if you're running a file with the tools already set up, you still have to choose in the software you're using what tool you have to use, and you have to go through those parameters, right? Trying to look up the feed rate, the spindle speed, looking at the tool diameter, and which is the compensation goes one way or the other. So all those things are a little bit similar to the laser, but you're not really worried, for example, the laser too much about the diameter of the beam. You're not worried about the length because you don't need to think about the length. So of course, when you choose the laser, you just click one button and pull the parameters faster than you do it in a in a CNC router. Yeah.
Perfect. Also, guys, if you have any questions, just feel free to ask them in the chat with anything that we're talking about, and we'll address those. So the next line is consumables. So no consumables tools for CNC routers, and actually put, lenses and mirrors are technically consumables for the laser, but if you do a proper job cleaning them, which, takes a couple of minutes per day, really, those lenses and mirrors usually would not break or pop. So what kind of consumables are there for CNC routers, Rene?
Yeah, CNC routers, you have to think first of the tool. Of course, tools have to be replaced when they get dull or when they get worn out. And of course, it's not only the fact that they wear out. Sometimes they can be broken. Of course, the most experience you have is not going to happen very, very often, but sometimes it happens, and it could happen in the middle of the job. So you have to have always spare tools. And if you're running a job that you need more than one tool, you have to keep spare tools for more than one. And of course, you need clamps, you need tool holders, and you need different type of tools and accessories. So with the laser, we can say that it's really not consumables. I'm not talking about the material you're cutting. I'm talking
Right.
about power. You just plug it into the wall, and the power is there. So there's no difference in tools you're using. You're always using the same beam, the same lens, and basically, yeah, not consumable in that sense. So you don't have to think about things like even blades or collets or things like that, right? Yeah.
Mm-hmm. Yeah. So, on average, again, when you work with a CNC, how many, roughly off the top of your head, tools would you use or have not use, but have in the background, if you need them or if they break?
Yeah, usually you need to have a full set of different tools depending on the materials. Like you may have tools for metals, may have tools for plastic. Each tool, if you are doing it properly, you should have a tool for each kind of material. Some are more generic, but you still have to have a backup tool just in case it breaks down. Also, you may have some other clamps or collets. So if you're doing a job where you need sometimes two tools, like for roughing and finishing, you at least need to have a couple of tools, one for the roughing, cutting, and one for the finishing. So implies you have to have backup for both tools, right? In a very, very simple job. But if you need to cut different materials, you will have at least 10 different kinds of tools, between tools for roughing, tools for finishing, right? And also depend of the things of the material. Some tools will have what we call the flute, which is the length of the flute, which is the depth the tool can be cutting. So sometimes even you can have two tools of the same diameter, but one is longer than the other, just to be able to cut thicker material than thinner material.
So the short answer, lots and lots of tools, basically.
Yeah, yeah. Mm-hmm.
Okay, sounds good. So the next point is internal sharp corners, and we'll show you guys differences. We've tested acrylic, thick acrylic with Ryerson University for CNC cutters and large format lasers, and we'll show you that in more specifics right after this slide. But Rene, if you want to kind of tell us what you mean by you can do internal sharp corners versus you can do them on a CNC machine.
Exactly. CNC machine, because of the nature of the milling, you always will have the radius of the tool. So no matter how small your tool is, you're always going to leave a radius. Especially it looks in when you're cutting internal corners. You may have to get adapted to having some radiuses there. So even if the tool is very small, you will always have a radius. So it means when you're doing a job, you cannot guarantee it's going to be a sharp corner. So either you have to modify your file or just let the machine do the radius for you. But you see, it's going to be changing the original setup. So if you want to do like a sharp corner in your file, you will never achieve a sharp corner in the machine when it's cut up, right? So it leaves the radius. It changes the shape of the letter or whatever you're cutting. But also, if you're trying to do things like inlays, for example, it's very difficult because you cannot easily insert a piece of material. So when you're doing an inlay where you're inserting one piece into the other, you may have to create a radius in every single corner of the inside part, or sometimes do some tricks like creating radiuses like a fish tail or something like that that you can allow the parts to get in. And in my experience, I used to work doing channel letters, and that was a challenge because in channel letters you have to fold the metal around the corners of the acrylic, and whenever you have the radius, it will interfere with the bend of the metal. So we used to do a lot of work in the files in order to either sharpen the corners or make a radius on the bend of the metal. So that adds more labor. So it's beneficial having a machine like this, a laser that can create those sharp corners. So you have to avoid all that extra work.
Yeah, and I actually did want to pull up the slides while we're talking just to show people the differences. So you can see here, like the laser actually went in and cut this portion here, while the CNC, it would not cut in a more detailed cut inside of the acrylic.
Right.
Okay. So let me go back to our first slide. Okay, so the next one is the flame polished acrylic edge. I mean, I think that's one of the most obvious one for people when they're dealing with acrylic. And again, this is like our R. You could see the flame polished edge versus the CNC. I think that's self-explanatory. You get that kind of crystal edge on the side of the acrylic when you're cutting in with the laser, and the CNC is more opaque. Did you actually ever flame polish the CNC pieces after they were done, Renee?
Yeah, exactly. If you were doing things like I said previously, like channel letters, they are covered with the metal. You don't need to. But if you're doing an indoor sign, right? So we sometimes have to do indoor signs or things like that, and the people always wanted to see that beautiful polished edge. We had to do a post process, polishing the edges, trying to achieve, and it's not going to be as perfect. And sometimes even polishing will change a little bit the edge, so you don't get the sharp corner on the acrylic because it tends to round it. And if you're not careful, you can ruin the job you did previously right after cut the piece, right?
And how long does that? I mean, like let's say if it's a letter like this, like if it's 6 inches by 6 inches, I mean, how long would flame polishing take?
It all depends on the size. It depends on the ability of the person doing it. But yeah, it's gonna take at least 1 minute to a couple of minutes to do it, right? But if you
and if you have 1,000 pieces,
every single letter, right, it's gonna be a lot of time. Yeah.
Perfect. Okay, so the next one is no force applied to workpiece versus needs clamping system. So I guess if you can kind of explain what kind of a clamping system are we talking about when we're talking about CNC routers?
Yeah, on CNC routers, when you're cutting a big sheet of material, there's two ways of working. You can have like mechanical clamping system, which is not the best one because most of the times the clamping is going to be in the way, right? So most of this, when people have the opportunity to have a bed with a vacuum table, usually you need to have like a sacrificial board or a waste board that allows the vacuum to suck in through it. So the sheet will be sucked down by the vacuum system.
What's this sacrificial board? What's that made of? Is that acrylic as well, or wood?
No, it's usually made of a porous material like MDF, or sometimes some machines come with a plastic bed, which has drills and channels on it to create some kind of vacuum. But usually you use a sacrificial board like wasteboard or like MDF. So that adds not only the fact that you have to consume that because it's a consumable. That's why it's a spoil board or waste board. So you're gonna have. I used to have a stock of that material because we used to change it. The more you work on the machine, you have to replace it. Even though you're careful and try not to use it a lot, it will create a lot of grooves, and you start losing suction, right? You start losing the flatness. So you have to plane it, waste it, the waste board. So that's an additional process. You will spend at least half an hour or 1 hour just planing the waste board to make it even. If you were able to do it up to a certain point, because if you plane it too much, it will warp, and then you lose the flatness of this. Also, another challenge was when you were doing this is that usually the waste board is because made of MDF, it will absorb some of the moisture of the environment. So
I see.
with the time, we will absorb moisture and will not get very, very good. So that's something that you have to add to your process. Is not only the time of preparing the waste board, or also the cost of replacing it. Some people are really good at trying to make the compensation of the tool good enough so that you can plane in a way that you don't gonna make deep grooves on your waste board. But it's not always easy, right? If the waste board is not even, you're always gonna have some places. It's not something that you just can flip over because you lose suction. So the ideal situation is to have a good suction. So talking about this vacuum bed, that's the problem, that you have to have it perfectly clean so that the machine is able to suck down the material. But another challenge is as soon as you start cutting, you're creating holes. So you start losing suction because it's air coming through. So most of the times at the very end of the file, you're gonna have a loose piece of sheet or a loose parts around. So it's a challenge always clamping and holding the parts. If of course it works pretty good when you have a really good bed, but the bigger the holes you create, the more loose they get. And at the end, you're gonna have the challenge, especially with small pieces, because you don't have enough surface area to suck down those pieces. So that's a big problem. So in the laser, we have the advantage that you don't have to hold it with anything, right? You're not applying any force to the material. It's just the laser cutting. So you can just literally drop the piece on the bed, and it will stay there. You don't have to worry about losing flying parts because of the tool rotating. Sometimes when the tool hits a piece, it will literally go flying, right? Sometimes
Really?
you need to have a good suction, also good pressure foot to hold it down. So I see that many times, and sometimes could be even a cause of a tool breakage, right? I'm not saying it always happens. Of course, the more experience you have, you can avoid those things, but it's always that challenge, right? And especially because of the holding system, you cannot cut very small pieces.
Right. Right. Interesting. Okay. Perfect. So let me go to the next one. Cleaner machine bed surface after the job is done versus a messy work area. Now, we're not saying, the laser would be completely clean. I mean, if you're doing multiple intricate pieces, obviously they would either fall when you take a piece of acrylic out or anything. But what do you really mean when you say a messy work area for CNC?
Yeah, when you work in the CNC, of course, you're removing chips from the material, right? You're cutting chips. So those chips, even if you have a very good suction system, there's always going to be chips around. So whenever you were running a sheet of material and you have to replace another one, because of the fact that you need a very clean surface for the suction, you cannot allow chips on the bed. So when you replace one sheet with the other, you always have to clean thoroughly the surface, even with a brush or with a vacuum. So it adds some time in between, the cuts of the pieces, right? You have to have a very good dust removal system, or you have to clean the table always after one job, after the other. And you have chips around the machine always. And no matter how good the suction system is, there's always some material left around. So you have to be really clean when you swap the material, even around the working area of the machine. There's always going to be like chips flying around. So it's not as clean, of course. Laser creates some kind of things, but laser is not a problem because when you go through the grid, you won't affect the part, right?
Right. And would you ever would you wear like safety goggles if you need, if you're doing wood with the CNC, like for the chips to fly or anything like that? Is that necessary?
Exactly. Yeah. Of course, it's always a recommendation. There used to be a sticker on the head of the machine, right, in the milling head, that will say you should use safety goggles and even ear protection as well. Yeah.
Oh, really?
Yeah.
Oh, interesting. Okay. So the next one is no need for tabs adhesive for small pieces versus need some kind of a holding system. What do you mean by that?
Okay, exactly. Like I was telling previously, when you need to cut small pieces, there's a few ways to do it. So some software comes with the option to do like little taps, right, to hold the pieces. Because as soon as you start cutting the piece, when you get into the end, the piece is gonna be loose. Especially if it's small, there's not enough suction. So in order to avoid for the part to move and get damaged, right? Because if it moves, it's gonna damage the shape of the part, or it's gonna come loose. So you can create little tabs that will hold the pieces in the sheet. So usually the operator have to be later breaking those tabs and cleaning them. So that adds labor, and it's very in labor extensive, right?
Hmm.
Cleaning every single one. Another way to do it, some people have figured out to do some like double-sided tape or some masking tape or double-sided film, which can help if you are very accurate in the cutting, that you don't go any depth. Like if you don't go too deep, you're gonna save that film. But if you go too deep, you're gonna be cutting the film, and at the end, you're gonna be peeling off that from every single letter.
Mm.
Also, that adds to the cost because you have to consider each time you replace the sheet, you will have to cover the whole bed with that thing, which is extra time, extra labor, and it will add to the price, of course, of the product, because you have to pay for the cost of that tape or that double-sided thing. So that could save in a way the wasteboard as well, but it's always more labor, right? So again, if you compare with the laser, which you don't really need that, you just drop the material on the top of the bed. So it's a winning.
Yeah, so I guess what we're saying is, when somebody thinks about the cost of a CNC versus a laser, and they would say, oh, well, the laser might be more expensive for whatever reason. I mean, these are the kind of things that you want to consider. I mean, how much time you're going to be doing flame polishing, how much time you're going to be clamping or replacing bits and pieces, cleaning the sacrificial bed table that you mentioned, putting the adhesive on. So it's just lots and lots and lots of processes and consumables for the CNC machine versus the laser. So that kind of justifies, if you buy, especially if you're buying a large format laser, that's the kind of things that you want to consider. The ROI, how much materials are you processing per day, and how much more cost effective is it going to be to have a laser versus a CNC machine?
Exactly the time you're gonna spend doing the job. Yeah.
Yeah, exactly. So the next point we have, and I can actually show one of the slides that Renee brought for nesting. So the materials for the laser machine, the materials are optimized for nesting, so there's less waste. While the CNC, there's more materials wasted during nesting, tool radius clearance needed between the nested parts. So I'm actually going to bring up the slide. Let me see if I have this. So these two slides. So, Renee, can you kind of explain what nesting is?
Yeah, if you go to the other one that is similar, we start with the mill. That one, no. Let me
Which
see.
one?
No, okay. This is a simple exercise. Let's say we're gonna do a sign. This is a 4x8 sheet of material, right? We're gonna do a big sign. And so the exercise is I'm gonna be doing many of this, like 10, right? So with the software, I'm nesting all the parts to optimize the usage of the sheet. So the next slide shows us when you do that nesting optimization, some software can do the real true nesting, and they can put all the parts, one beside the others. You're gonna go to the next slide, please.
This
This
one?
one. Here, I did the calculation with doing. I think it's 5 parts there, right, of them, and I want you to catch your attention to the top corner, upper left corner, where it tells about the clearance and the tool. In the very top, I put a tool, which usually you can use any size of tool, but you don't want to use a very small tool. Other way, you're going to be taking too long, right? And it's more risk that the tool is going to break, especially if it's a thick material. So usually people use a 1/4 inch or 3/8, which I did it with 3/8, which is the most commonly used for cutting. This is like cutting letters for a channel letters, for example, right? So you see the diameter of the tool in the top, the clearance that I have to leave in between the parts, right? And a little bit of clearance on the edge of the material. So because we have to add the radius and that clearance, you're wasting some material there, right? So at the end, you see that this calculation of the nesting is showing me that we're gonna need 3 and a little piece of one more sheet. So we're using 3 full sheets and just a little sheet per one letter in the corner. You see in the right image. That's with the milling machine. So if we look at the next slide, I did the same exercise, same amount of letters, everything the same, but I was able to put a smaller clearance because I'm just using the diameter of the beam of the laser is even smaller than the clearance that I put there, but I still left a little bit of room. And you can see that we are using just 2.5 sheets of material in this simple exercise.
Oh, wow.
So we're saving material because of the fact that we don't need to leave that much clearance in between the parts, right? And of course, we are not worried about like the parts are gonna be moving around, or we don't have to use tabs. We don't have to use. Just imagine having to tape down all those pieces or having to leave tabs on those pieces, right? Especially because they're so close, so tight. So this is a great advantage because we are saving material. So in the long run, if you're doing production, you're going to be saving more material with the laser than you can save with the router. So that's the whole thing, right?
So you're basically saving almost half a full sheet, right? Yeah. Like in this case, this is
the sample, right?
The part you're saving with the laser machine. Yeah, and you multiply that by a full days of production, and that could really add up.
Right.
Okay, so so that's nesting. Now, I mean, do you have any like rough estimates of timing? Like, why would a laser be? Is it just generally faster than a CNC router?
Yeah, exactly. Because in CNC router, you're limited by the size of the tool. You're limited by the hardness of the material. You're limited by the length of the tool. Sometimes one challenge is even if you want to use you want to cut a thick material. For example, probably you've seen some of the videos we have put of the cutting a 1-inch acrylic. You want to cut that thickness of acrylic with one tool in one single pass. You're gonna spend you're gonna need a very long tool, which is it's gonna be vibrating a lot. So then you have to do it at least in 2 passes. Or even if you're doing 1 pass, you need a very big tool. Then you're gonna be having a bigger radius. So it's a challenge. So when I used to do these thick letters, I had to use the first 2 tools. One for doing the big cut, and a small one to doing the little corners radiuses. So it will double the process, right? Which in the laser we can do it in 1 single pass. Just that fact helps. Again, if you want to do it with a smaller tool, you can do it in 1 single pass. But again, you have to slow down a lot because if you have a long tool with a long shank, it's a lot of possibility is going to break. So you have to slow down your feed rate, right? And you need a lot of spindle speed as well if it's a small tool. So just the fact that you can do in the laser in 1 single pass with the proper laser tool, right, and have it finished, it saves a lot of time, right? You're doing a mechanical cut, so you have to slow down if you don't want to break your tool.
And just on a side note question, I mean, can you actually do any kind of fabric or leather with CNC?
No, never tried. I don't think it's going to be good. Of course, yes. No, it is very challenging.
Okay.
Those materials, no. For example, there's materials you can cut in the CNC, you cannot do in the laser, and vice versa, right? Like one is one of the materials that people always ask me. It's not that the laser cannot cut it, but the problem is that because you have aluminum and plastic combined with the alu panel.
Sorry, which material is that?
It's what they generically called the ACM, aluminum composite materials, which goes more like alu panel or alu bond, which is 2 layers of aluminum and plastic in the middle. And because of the plastic, if you try to cut it with a laser, of course, you're going to heat it so much, it's going to melt the material. So it's not going to be nice. Of course, it's one of those materials you cannot do in the laser. Same thing as PVC. But the most of the other materials that you can do in the laser, you're going to see an advantage of cutting with the laser in terms of speed, right, compared to the CNC router. Yeah, and you can cut cardboard, you can cut foam board, leather, fabric, those things. Yeah.
Okay, and so we have 2 more points here. So quiet operation of the machine, I mean, relative quiet. You guys will see a demo in a few minutes. When it's engraving, there's still obviously sound and noise, and if there's any kind of vacuum or vacuum system for these large format lasers, they do make noise. But I mean, I've never actually heard a CNC machine, Renee. How, like, what is the noise level? I mean, if like, what would you say a laser machine versus, like, out of 10 noise level, 10 being the noisiest, the loudest, and then like a CNC?
Exactly. I will say it's 10-5, right? 10 for the milling and maybe 5 for the laser. It's
Okay.
because in their CNC router, if you have a machine with a vacuum system, vacuum bed, you can have the pump running for the vacuum, which is very noisy. You can have the spindle itself that is noisy. Even the best spindles, they will always make noise. But also the tool itself, cutting the tool against the material creates a big noise. And if you have a long tool because you need it, it's going to vibrate and it's going to create a high pitch noise, vibration. Plus, if you have your vacuum system running as well, the dust collecting system. So when you sum all of those, I used to have
Earplugs?
earplugs, and the operator used to have it. Even though we try to isolate those in some other rooms, something you cannot isolate is the spindle noise and the tool cutting the material, especially hard materials, rigid materials, sorry, like acrylic and plastics that are hard. You feel more strong the noise. So of course it's noisier than a laser. Laser, the only thing that could make noise is having the vacuum for the fumes, the extraction system, and probably a little bit of the motors and the cutting, but it's nothing compared to the noise that you can get in the CNC router. Yeah.
So, for example, I mean, if you're doing kind of prototyping with a team of people, and you go on the laser and CNC, go back like to the computer nearby, test it, go back and forth. You want to be able to communicate with people around, but if the CNC is running, it's definitely going to be a deterrent in that regard, right?
Yeah, exactly. You have to literally shout out because it's really noisy, and yeah, and it's actually we measured the decibels in the shop many times, and it was on the level that you were forced to use. If you want to keep your ears safe, you were forced to use ear protection
Wow.
because the decibels were really high when everything was running together. It was terribly noisy. Yeah.
Mhm. Okay, so we got our final point here. So machine stop, minimum chances during the job for the laser, and high chances during the job during the CNC for tool breakage. So what can you explain that, Renee, for us?
Yeah, of course. When you start running your laser, if your laser, of course, in a very unlikely event that the laser is gonna stop for any reason because anything that can stop it, which is very unlikely, you will never have to be worried about that the beam is gonna be worn out, right? But with the tools, even if you calculate properly, especially you're running a job, let's say the job that I showed in the nesting, right? You're cutting so many letters that probably the tool is gonna wear out very fast. So you're gonna be always taking there. You cannot really identify exactly when it's gonna break, when it's gonna lose the edge, right, or the sharpness. So even if you're very experienced, you may say, okay, I know that I can cut, let's say, 100 sheets with a tool, but anytime the tool can break for many reasons. It could be different hardness in the material. It could be that it got stuck in a corner. It could be that it moves and hits something. So tools can break because it just gets dull and stop cutting properly and can be broken. So it's many times we have that issue that we were in the middle of the job and we had to stop, change the tool because it broke. Then you have to recalibrate the tool, put it back, calculate the length, and go back to where you were running. And depending on the machine you have, sometimes it was easier than others, right? So I'm not saying it happens all the time, but it's a high risk that is going to happen, and you're always facing that.
So if a tool breaks in the middle of a job, like I mean, I haven't been around CNC machines, so I don't know this, but does the machine stop right away, or does the operator have to stop it?
The operator has to stop it. Yeah, machine has no way to notice it, right?
So
It's like
the operator always has to watch the milling process?
exactly, yeah, like
Really?
yeah, unless it is a really I will say a very sophisticated machine that can measure the tool or something like that. Some people can, create a routine to go and measure by itself, but no. It's really no way. People will think, oh, could be like a sensor. No, because the machine is strong enough. It's made to be strong and be pushing, right? So machine is
Mhm.
not gonna stop because of the tool breakage, right?
Mhm.
And sometimes it will happen. Sometimes if you leave the machine unattended, you come back, you realize the tool was broken and it was just running into the air, right? Just
Really?
wasting time. But
Yeah,
and
I mean,
I'm not saying it happens all the time, but it's always that risk.
we would never say leave the laser unattended, obviously, but I mean, there's definitely, you don't have to always double check and make sure that you know there's no tool to break basically on a laser machine. So yeah, that's definitely that's a huge plus. Okay, awesome. So I'm gonna actually show you guys a couple samples before we get to this demo. This is something that Ryerson University, their FCAD lab, did for us. So I'll show you guys the pictures because it's going to be hard to see on webcam. They have both machines, and we're going to actually do a video with them where they're talking about, you know, where the CNC is good and where the laser machine is good. But, you know, when we're talking specifically on acrylic, I mean, I showed you guys the slide. There's one thing here. For the engraving, obviously the CNC does take quite a long time for the engraving, and you can see the mill lines right on the piece. I don't know if you could see this. This is the CNC. You can see these kind of marks right on the engraving, and then I'll show you the laser. The laser is perfectly like a perfect engraving. Basically, you can't see any kind of marks by the laser.
Yeah, you have to think of the fact that this is some vibration, right, transferred to the part because of the mechanical process. So even if the tool is so precise on the material, you still leave some marks. Yeah.
Yeah. So we showed you guys this slide. Of course, this is the flame polished versus opaque edge. This is another sample that I think is interesting. So we actually asked them to do a bunch of internal cuts inside the acrylic, and they could not do it with the CNC machine. This is, as you can see, it's almost like just like a kiss cut. It's not. There's nothing going through. Whereas the laser, you can see that it's a full cut right through the acrylic. And then when we asked them to engrave, so you can see on the red point here, the engraving is actually, they can engrave the little details, but because they used, I guess, a larger head on the CNC machine, you could see the engraving there where it's just circles. So that's another difference there. The next one, if you could look at the K, so the laser machine actually fully engraved the letters inside of the bakery sign, while the CNC did not. Sorry, let me show you the CNC.
Yeah, you can actually do it, but maybe you have to replace the tool, right? And then it's another process, right? A very, very small tool, and you need a lot of spindle speed there if you want to achieve the right thing. Yeah, and it will add to the process a lot. Yeah.
Yeah, and then we mentioned this part as well. So the laser went inside this section, while you can see here the CNC did not. And you guys can't really see the details. I'll try to show you. So this is the laser machine, the 1890, and I'll show you the CNC. So, you know, when you're trying to engrave small letters, you're going to run into trouble with engraving on acrylic for the laser versus the CNC. There's a couple of samples that where they couldn't actually do on the CNC machine, like this, for example. This is again, acrylic. You could see the very thin cut here, like it's very thin. Like I could snap it off, but the laser can do this. While they said they tested it on the CNC and they couldn't. And finally, the last one, again, it's this Trotec logo, the intricate cuts, like the deep cutting into the E. They said it just kept snapping. And also you could see the little engraving of the Trotec there that they couldn't do. So yeah, it's just a couple of samples that we wanted to show you. Again, we'll have a full video with Ryerson talking about these samples in the future. With all of that being said, I think we're ready for the demonstration. Josephine, hold on. Let me just put you back in.
Cool.
Okay. Yeah, we can hear you. Just
perfect. Hey, everyone. Hope everyone's doing well. So I'm actually going to hop onto my computer because I already set everything up. So what I'm going to do is send the file. The software is virtually exactly the same as any other job control for, say, the Speedy 400, 360, 100. So if you're upgrading from a smaller machine to a large machine, the learning curve is quite minimal. So same process, I have my file set up, I go to print preferences, and the window is exactly the same. So you have the ability to minimize the job size, which I have right now. I've selected the power to cut 6mm acrylic, which is on the bed. And the process mode, resolution, cut line, halftone, exactly the same. So I have my settings all good to go. And all I have to do is select print. I'm not going to select print right now because I already have a file sent over.
Josephine, just a quick thing. So
Yep.
just wanted to mention, with the laser, like Josephine said, it's the same job control, mostly the same job control that you would see on a Speedy series.
Yep.
So if you want to see how the software works, it's actually quite easy to learn. We have a webinar for job control. I'll post the link to the description of the video if you kind of want to see the basics of job control.
Yep.
And Josephine was using Corel to make the design files, but you can use any design software. It basically works like a print driver, so you can use Illustrator, Corel. You can use any kind of CAD software where you would use it, so you would print it to the job control. I just wanted to add that.
Thanks. I guess the only difference is for large format lasers, you have a special feature called Tandem. So what the Tandem Assist is, it splits the laser into two working zones. So for example, if I go to settings, so this feature is really good for optimizing production and manufacturing. What you can do is you can have one side that is cutting a job, and then the other side you can unload the parts or load a new material. So for example, I'm going to determine the tandem mode, applied, and press OK. So let me zoom out a bit.
Yeah, I just want to add the tandem mode. It's there, so if the machine is cutting a piece of wood or acrylic on one side, the operator can actually place another piece on the other side of the machine, so you can actually have a constant, continuous workflow.
Yeah. So the point of this is you're not stopping the machine; you're always producing and manufacturing your piece. Also, nice feature if you could switch back to the camera quickly. Perfect. You notice that you have access to the laser machine on all four sides. On each side, you have buttons that you can activate the tandem mode. So for example, if someone else is on the other side unloading and putting a new sheet and they're ready to cut, there's a button to press play to run that job. So you don't always have to run back and forth and run in circles to run the job. There's a button on each side to turn it on. Okay. So hopping back to my computer, I'm going to turn off tandem mode because we won't be using that. All right, so we are cutting 6mm acrylic. I'm going to autofocus. So we're using sonar technology to allow the laser to focus to the material. So once I have it in focus, I already have my table exhaust and head exhaust turned on. So all I have to do is double check my settings because I always like to double check, and then hit play. So right now it's going to engrave and then cut after.
Yeah, so the settings, Josephine, can you go back to the settings? I don't know if you can. Just wanted people, if you haven't seen job control ever, the settings is really, there's 16 different colors that we assign to the artwork file, and we assign a power setting, so how much power we would use for the engraving, or how much power we would use for the cutting, and the speed. Not just power and speed, but that's basically it. So the more power, the less speed you use. Let's say on an engraving, the deeper the engraving will be. The thicker the material of acrylic, again, more power, less speed. So that's where that's what those settings are. And so right now the machine is cutting. How big is the actual piece itself?
It's about 2 inches by 2 inches. Oops, and I should have done this before, but there is a feature on job control that calculates how long the job is. So for example, it shows that it takes, let me update it, 40 seconds to engrave and 20 seconds to cut.
Yeah, Renee, I think that they have the same. Do they have the same thing in CNC software to calculate the job amount?
Yeah, yeah. Depending of the software, you can do an estimate of the time. It's not 100% accurate, but gives you a really good idea. And depending on the software, yeah, it will tell you an estimate. But you have to be sure that doing the estimate, you have the right exactly the right feed rate and swing speed fixed parameters, right? Yeah.
Perfect.
It really is easier to be more accurate in the laser than in the milling machine because of all the movements. Because the machine does two kind of movements: one in machining, one in the air. So depending on how fast it moves in the air and on the over, yeah, is what we call the positioning moves against the cutting moves, right?
Mm-hmm. Yeah, Josephine. So Josephine's just taking the coating off the back, and if you want to, so you see that's the engraving there. So very, any kind of letters or intricate engraving can be done. I mean, the main focus of the laser machine is for cutting, but you can see the engraving can go very well as well. I mean, if you remember our, Speedy 300s, the engraving is extremely fast. But again, you could still do engraving and cutting with this machine. Can you show us the edge quality, Josephine, as well? Yeah, so there's that, the flame polished edge. Perfect. And then we also wanted to show you guys a fabric on the laser machine. Do we have that as well, Josephine?
Yep, I'm just going to take a minute to set up.
Perfect. And Josephine, how is that, like 10 mil acrylic?
That is 6 millimeters, so about a quarter inch.
So quarter inch, and it took us about a minute to cut and engrave. So just to give you guys a brief, outlook of how long the job size will take.
I just want to clarify something because when you asked me previously, you can cut the fabric in a CNC machine. There's ways to do it, but you need a different kind of tool, right? You need a knife head. Either it's an oscillating head or a tangential knife. And if you need another accessory, you need another tools. And of course, because it's a blade, you are subject to the same thing. When the blade gets dull, gets worn out, you have to replace it, right? So it adds, again, more tooling and more accessories. We're using the same laser head to do all these materials, right? That's the difference in the laser.
Right, but you can't actually engrave the fabric like you can with the laser. Like if it's
No,
leather,
you can
you
cut
can't.
it, but you cannot engrave it. Yeah.
Right, yeah, because the laser, obviously burns the material, so we can make it precise enough. I mean, we have tons of leather videos on our YouTube channel where we would like engrave raw hide leather or even finished leather to make patterns and all sorts of stuff. So, sorry, Josephine, I'm going to show them what you're doing.
Cool. So I have 4 layers of cotton canvas placed onto the machine. I also have a setting set up, so everything looks good. So I use my laser to help position my job, and I just clicked and dragged my job to the laser pointer. I'm not going to do engraving for this demonstration, just cut. So
Yeah, go ahead. Sorry, Josephine.
no worries. So I'm going to hit. Oops, I forgot to reset the job because I ran it already.
Yeah, just to explain, the white background around the A is basically the virtual background, the virtual table of the physical table of the machine. So that there's a laser pointer on the head where Josephine can see where she wants to put her job, and then she would drag the job and snap it to that laser pointer, so she knows exactly where the cut's going to be.
Yep. And my calculation tells me that this job would take 8 seconds. So I'm going to hit play.
And again, we don't need a lot of power for this, so we can actually use 100% speed and 100% for this. Oh, sorry, not 100% power. You obviously don't want to use too much power on fabric, but yeah, you can use 100% speed.
Okay, and there we go. 4 layers of cotton canvas. Okay. And that was less than.
Can you show that just a bit closer?
Oh, yep. Oh, there we go. With natural fabrics, you won't get a sealed edge, but if you work with fabrics with like polyester blend, you get a sealed edge. Okay.
Mm-hmm. Renee, we just had a question. What advantage does a laser cutting have over water jet cutting? Are you familiar with water jet cutting, Renee?
Familiar with, yes, water jet? Yeah. Mm-hmm.
Yeah. Do you know what advantages a laser cutter might have over water jet cutting?
Yeah, for example, with water jet cutting, if you can get really good edge finishing, but you still cannot get like a polished edge, right? Because basically what it does is something similar that you can get on the milling machine. Water jet are good for things like stone, especially things that you cannot cut with a laser, right, or a milling
Or
machine.
metal? Yeah.
In metal, yes, you can cut with laser as well, of course. The good thing is that it won't leave that burnt edge, which if it's a problem, even with a very powerful laser, you can cut, yeah, metal, but you still can have a little bit of burnt edge, right? But with the water jet, you don't. Water jet are good really for these materials like stone and metal, aluminum, and you can get yeah, something similar to the laser. But of course, some materials you cannot cut with the water jet. For example, if you use for fabric or leather, you won't be good for those materials, right? Something that can get wet or gonna be has to be material.
Yeah, and I just want to confirm our lasers, like our SP lasers, are not meant for metal cutting. I mean, when we talk about metal cutting lasers, that's a kind of different ball game with a whole different wattages and tables and that sort of thing. So yeah, but I think Renee was talking just in general.
Yeah.
Perfect. I think that's it, Josephine. I think we're all good. If there's no more questions, you know, if you guys actually need to reach us, I'm just going to put a quick number of where you can reach us to contact us. If you're looking for quotes or any additional information on large format laser cutters, again, we have 4 locations across Canada: Calgary, Vancouver, Toronto, and Montreal. And I just wanted to say a big thanks to Josephine, Miguel, and Renee for this webinar. If you guys have any more questions, leave them at the comments below. We'll post this video in probably the next couple of weeks. So you won't get to see the recording right away, but in about 2 weeks, we'll have it up there. Okay, I think, oh, sorry. I think there's one question that just popped in. With your letters that you have cut, is there iron on material on the back? As she turned it over, it looks a bit dark. Sorry, I got here late. Okay, no worries, Richard. Yeah, so there's nothing iron. The material is actually canvas fabric. And because we're using 4 layers, there could be some kind of burning at the back of the last layer. So we could just adjust the settings to basically have a little bit less power to prevent that burning. But no, there's no any kind of iron or anything like that on the material itself. I think with that, we're going to call it a day. So thanks, everyone. And then keep watching our YouTube channel for more webinars. Awesome. Thanks, guys.
Okay, thanks.
Take care. Have a good one.
Okay, have a good one.